Hey guys, in this video we are going to evaluate a very cool limit. What is the limit of 1 all over n multiplied by the inverse of the natural log of n factorial, all divided by n all over e raised to power n multiplied by the square root of 2 per n as n tends to infinity? To do this, we first of all recall Stirling's formula for n factorial. From Stirling's formula, we have that n factorial is approximately equals to n all over e raised to power n multiplied by the square root of 2 pi n. Now, if we take a look at the denominator of the expression given first, we find out that it is the same as Stirling's approximate formula for n factorial. Now, to be able to evaluate the limit problem, we have to know what is called Stirling's asymptotic formula. And Stirling's asymptotic formula is simply just a product of Stirling's approximate formula for n factorial and an infinite series. The reason why it is called an asymptotic formula is because it consists of an infinite series. We decide to call this asymptotic formula equation 1. And when we divide both sides of equation 1 by the product of square root of 2 pi n and n all over e raised to power n, we have an infinite series on the right hand side and an expression on the left hand side, which we decide to call equation 2. Now we will take the natural log of the expressions on both sides of equation 2, and when we do that, this results to a new equation which we will decide to call our equation 3. Now, after taking the natural log of the expressions on both sides, we decide to take the limit of these expressions as n tends to infinity. And as n tends to infinity, the limit of the expression on the left-hand side will be exactly the same as that on the right-hand side. When we do this, we'll have an equation which we'll decide to call our equation 4. The exponential function e raised to power x has an infinite series representation, and it is given as e raised to power x equals summation of x raised to power n all over n factorial as n moves from 0 to infinity. Replacing x with 1 all over 12x for e raised to power x, we have an entirely new infinite series consisting of 1 all over 12x raised to power n instead of x raised to power n. From equation 4, as n tends to infinity, the expression on the right hand side can be replaced with the natural log of e raised to power 1 over 12n. That means that the expression on the left hand side is the same as the natural log of e raised to power 1 over 12n as n tends to infinity. It is already known that the natural log of e raised to power 1 all over 12n is equal to 1 all over 12n. Then, therefore, the limit on the left hand side of equation 4 as n tends to infinity is equals to 1 all over 12n. Now, if we take the inverse of both sides of this new expression, we have something entirely new. Finally, dividing both sides by n, we have 12 to be the answer to this problem. Thanks for watching. Please like and subscribe. Feel free to ask any question in the comment section. Thank you.